Hello gems, welcome back to another video. So this is mock test number 7 for BITSAT 2024. Okay, so all the questions in this mock test are from Fodu Club's BITSAT question bank, one of the most relevant sources of questions for BITSAT. Okay, first of all, I present my thanks to Fodu Club for allowing me make this video. Okay, the book as of now is not available on their website. So it will be available around for BITSAT 2025. So if you are somebody who is going to answer BITSAT 2025, do check it out. Also, besides the book, they also provide BITSAT test series. Okay, so if you are somebody looking for the test series, relevant test series for BITSAT, do check their website out. The links will be available in the pinned comments and also in the description box. Okay, so with that being said, thank you Fodu Club again, and let's begin with the video. Question 1 and 2 over here to kick things off for mock test number 7. So in question 1, we are given a particle with its x and y coordinate as a function of time. We are supposed to conclude either on the acceleration and the speed. Which of the following statement is true? Okay, so we know if we differentiate this once, we'll get the velocity. Since coordinate are given, differentiate it once, we'll get velocity. Differentiate it twice, we'll get the acceleration. Okay, and hence we can substitute the time and make conclusions, right? So let's find the velocity in the x direction. That will be given as dx by dt, right? So that will be t square. If you differentiate, it is 2t, and if you differentiate this, it is 2, right? Then vy in the y direction, we have to differentiate the y coordinate. Okay, so 2t square, differentiate that, 2 comes down, 4t, and if you differentiate t, it is simply 1, right? So now let us substitute t is equal to 0. Let us check this statement. Okay, if the speed is 0 at t is equal to 0. So if we substitute t is equal to 0, okay, so this will give us 2, right? This will be 0, this will give us 2 in the negative direction. We substitute t is equal to 0 over here, we'll get 1 in the negative direction. So the point is you are getting some velocity in the x and y direction, and speed, if you know, it's just the magnitude of the velocity. Okay, so basically this will give you the speed. So you can see that the velocities are non-zero, the component in the x and the y directions are non-zero. So hence the speed will also be non-zero at t is equal to 0. This statement is false. If you substitute t is equal to 0, it is non-zero, right? We have non-zero components, hence non-zero speed. Okay, let's check this one out. Speed is 3 meters per second at t is equal to 1 second. Okay, so if we substitute t is equal to 1 second, okay, in this, v of x at t is equal to 1. Okay, so what do we get? This will be 0, right? If you substitute 1, that will be 0. If you substitute 1 in vy, what will be that? This will give us 3, okay, and which is true, right? Speed will be 3, this is 0. So you just have to substitute 0 and 3. Basically, you will get 3 only at the end of the day. So 3 meters per second at t is equal to 1 second. You can check the other statements through also, because but it's single correct, so you know that you have reached the right answer, which is option D. You can also check for acceleration if you're not convinced. So acceleration in the x direction will be, if you differentiate the velocity again with time, so here you'll get 2, right? And acceleration is in the y direction. If you differentiate this again, you'll get 4. Okay, so you can see that the acceleration is non-zero, right? It's not always 0, rather it's always non-zero. Okay, and if you see the acceleration at t is equal to 1 is 0, it's constant, right? It's not 0, it's never 0, I say. Okay, so yeah, speed is 3 meters per second. That is the correct choice. At t is equal to 1 second, we saw that speed is 3 meters per second. So that's about this question. Let's move to this one. The aerial velocity of the planet of mass m, okay, if a is the aerial velocity of the planet around the sun, okay, the planet has a mass m, you are supposed to tell the angular momentum. Such a simple question, right? If you know Kepler's second law, okay, you can solve it easily. Basically, the second law says that aerial velocity is constant, right? So, and the value of this is aerial velocity, right? I'll use area as small a because here you have used aerial velocity as capital A. Okay, so the aerial velocity is rate of change of area by time, and this is given as L by 2m. Okay, mu actually, but the mass of sun is massive as compared to the planet, so you just have to take the mass of the planet in account. Okay, so L by 2m. So that is the aerial velocity. You are supposed to find the angular momentum. Angular momentum is L over there. So that will give us 2ma. This perfect relation is available in your NCERT. and you can remember it from now on. Okay, it's one of the results from Kepler's second law, right? The aerial velocity is constant. So 2ma, angular momentum is 2ma, which is option B is correct. Okay, such a simple question. So let's move to next set of questions. Question 3 and 4 over here. In question 3, we have been given that rho is the density of a material, of a wire, and sigma is the breaking stress, meaning that is the maximum stress that the wire can take before breaking. Okay, you are supposed to tell the greatest length that can hang freely. Now as you are adding the length that is hung freely, okay, basically you are adding mass, right? So more and more weight force is acting, right? Weight is a force, so the force that is acting on this freely hung wire is its own weight, right? So this will break under its own weight. Okay, so basically sigma is stress, right? So force per unit area. What is the force acting on this wire? Is nothing but its own weight, right? Mg, mass into acceleration due to gravity. The own weight is acting on this wire. Okay, so this is the maximum stress that the wire can take. So from this we have to reach the maximum length. Okay, so mass is not there somewhere mentioned in the question. So mass we have to convert it into in forms of length. Okay, mass we can write it in forms of density as density into volume, right? Because density is mass by volume, so mass is density into volume. Okay, and volume can be written as area into length, right? So area of the wire into length of the wire. So pretty simple. So sigma is rho al. So in place of mass I am substituting this. This is g, and in the denominator we have a, that cancels with the 1 on numerator, so we get sigma as rho Lg. So sigma as rho Lg. Okay, we are supposed to find the maximum length. Okay, so L will be equal to sigma by rho G. Okay, so this is the maximum length that your wire, the freely hung wire, can be of, so that it does not break. Okay, so the wire basically breaks under its own weight, like people break under their own egos. Okay, anyways, that became deep. So the correct option over here is option D. Okay, sigma by rho G. Another way of doing this question, you can see that this sigma rho are all dancing around in numerator and denominator, and in such cases you can use dimensional analysis. You can apply dimensional analysis on the options and see which one is giving you length. Okay, only this one will give you length. You can check it out. Okay, let's come to this one. A crystal has coefficient of expansion this. Okay, so linear coefficient of expansion is this in one direction. So basically linear coefficient of expansion, and in the directions right angle. So suppose this is in the x direction, so this is in y and z direction. So 231 in every direction, right angles to it. So y and z we have 231. Okay, you are supposed to tell the cubical coefficient. Now gamma, if you know it simply, will be 3 times of alpha, right? So where does this come from? So basically this is equal if all the 3 linear coefficients are equal in the x, y, z direction. So you add them alpha, 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 and you get 3 alpha. Okay, so gamma is the cubical coefficient or the volume coefficient. Okay, so basically you obtain gamma by adding all the alphas. Okay, so here they are different, so I am writing them as alpha 1, alpha 2 and alpha 3. If they were equal, basically gamma is 3 times alpha, cubical coefficient is 3 times the linear coefficient. Okay, so but here they are different, so we are adding. Okay, so 13, 231 and also 231, right? So 13 in x direction, 231 in y and 231 in z, and also we have 10 to the power minus 7. Okay, we are supposed to tell in the units of 10 to the power minus 7, so we can ignore that. We'll only focus on this value. So 230 is 460, 462 and 13, 475, right? 475 and that power of 7, okay, minus 7. So 475, option C is correct. Okay, such a simple question. Cubical coefficient is the sum of linear coefficient. Okay, this is actually the relation that is provided, might be there in your NCERT, but this won't be there. Okay, so you are supposed to use this logic. Okay, so yeah, that's about these 2 questions. Over to the next set of questions. Question 5 and 6. In question 5, we are given a figure in which this battery is 4 volts and each of the plate of the capacitor has surface area this and the distance of separation is this. Okay, they are this meters apart. Okay, you are supposed to tell the excess electrons on the negative plate. Okay, the figure is useless actually. Okay, so basically what we'll do, we'll find the charge on the capacitor. We can use Q is equal to CV, and then we'll use Q is equal to Ne, quantization of charge, right? And from here, if we divide this Q by E, we can find the number of excess electrons, right? Basically, the charge is quantized and it is given as Ne, okay? So here C, we have to find using A epsilon naught by D. Okay, C is A epsilon naught by D because we are given the dimensions, right? Area is given and then we are given the distance between the plates, right? D is given, okay? So we have to find C using that, okay? So A is, so we'll find this out. Q will be, A is surface area is 10 to the power minus 2 and then we have epsilon naught 8.85 into 10 to the power minus 12, okay? And then we have the voltage as 4 volt and then we have the distance which is 0.1 into 10 to the power minus 2. I can write it as point or I can write it as 10 to the power minus 3, right? So I just shift the decimal to the right, so that is one more negative power, right? So now let us solve the powers of 10. So this is 8.85 into 4 and we'll have this as 10 to the power minus 14 and this goes on top as plus 3. So minus 11, right? Or minus 9 and this is plus 2, minus 11, okay? So this is the charge, okay? Now let us use Q is equal to Ne. So we have to divide Q by E to obtain N, right? So N will be Q by E. So Q is this 8.85 into 10 to the power minus 11 by E is, let me clean that up, okay? So N will be 8.85 into 10 to the power minus 11 divided by, so there is also a 4 over here, right? And we divide that by 1.6 into 10 to the power minus 19, right? That is the charge on electron. You are supposed to know all this constant, epsilon naught, then the value of E, okay? This is useful. So here what will we get? So basically if you see something 2 point, right? Because you can see 8 foci is 16, 8 foci is 32, 32 divided by 16 is around 2, right? So 2, something greater than 2 because it is around 9, right? So something greater than 2, so 2-ish, okay, over here. So this will be around 2.2-ish and then we have 19 and this, what is the power? So the, yeah, you can see the power is changing over here. So 19 and this, it will be the power, I think, okay, I have to do this. So this will be 10 to the power 8, right? I think this will be 32, okay, this is 1.6, so this will be around 22, okay? Because if you see this will be, suppose if we see 8 foci is 32, right? And this is 1.6, okay? So we have to say 320, so I multiply by 10 on numerator and denominator. So this is around 20, okay? And since it is 8.85, I'll say it's 22, around 22. So if you see this is around 22, so we can say it is 2.2 moving to the left. So add this power 1 to the power, so that is 10 to the power 9. So 2.21 into 10 to the power 9. Okay, I hope that is clear. We found Q using CV, C using the dimensions. Okay, Q is found, N is basically Q by E. Okay, so Q by E, just calculate it, answer will be around this. Okay. Now let's come to this. Here we have been given the RMS speed of hydrogen, nitrogen and oxygen molecules, okay, as Vn, Vn and Vo respectively. We are supposed to tell at a given temperature what is the order, which is the fastest molecule, okay. Now the RMS speed is basically given as under root 3 RT by m, where m is the molecular mass, okay, mass of the molecule, okay. So even if you don't remember this, you can only remember the relation as this, okay, that the your RMS speed is basically inversely proportional to square root of mass, okay. This type of questions are framed from kinetic theory of gases. They can ask you to find the ratio of different gases. If you know their mass, you can directly find the ratio, okay. But here we are just supposed to find the order. We can see that which mass will be the highest. Mass of oxygen is the highest, right? First comes the mass of hydrogen molecule, okay, H2, 2. Then we have mass of nitrogen, about 14, right, 7, 14. And then we have mass of oxygen, okay. So this is the order of mass. the velocity is inversely proportional to that, inversely proportional to the square root of it. So we'll have the order of velocity inverse, okay, which will have the highest velocity. Okay, I made a mistake over here. So this is the highest, okay, oxygen is the highest mass, hydrogen is the less, nitrogen, hydrogen, nitrogen, oxygen, right? So that is the mass order. So this order will be opposite of that, okay. So hydrogen will have the highest speed, so I'm just changing the sign, nitrogen next, then comes oxygen, lowest speed, highest mass, lowest speed. So V, H, N, O, okay, so option B, okay. So basically you have to see the relation with the mass, okay. So that's about these two questions. Over to the next one. Two questions on the board here. In question 7, we are supposed to tell the wave equation for a wave which is traveling in the positive x direction. Amplitude is given, velocity is given, and the wavelength is also given. Now let's filter this out. We can write the displacement y as you can see a sine kx minus omega t, okay, or I'll write omega t minus kx, okay, whatever. Why minus? Minus because the wave is traveling in the positive x direction, right? So this two, the coefficient of t and coefficient of x should have opposite signs. So omega is plus and k is minus, okay, or vice versa, okay. So that gives us the condition that the wave is traveling in the positive direction. If the wave was in the negative direction, both of them should have the same sign, okay, same sign for both the coefficient means the wave is traveling in the negative direction of this coordinate, okay. So your opposite sign means traveling in the positive direction, remember that, okay. And a is given, so a is 0.2, a is 0.2 everywhere, okay. So that is not the point of difference over here. We can find omega and t from this given omega and yes k from this given information, and we can compare later, okay. So k we know as wave number, right? Wave number is 2 pi by lambda. So we are given the value of lambda, we can find k. So this will be 2 pi by 60 or pi by 30, right? K is pi by 30, pi by 30. Okay, so if you take this and you can see this is pi by 30, this does not give you, right? So we have filtered actually, so this will be the correct choice, right? No need to find omega also, only this one will give you pi by 30, right? If you want to find omega, you can. We are given the velocity, so omega by k, right? Velocity is the coefficient of t divided by the coefficient of x, okay. So this is how the velocity of a wave is given from the wave equation. So velocity is given, k you already know, you can substitute and find omega. So omega will be k times of v, k is pi by 30 into v is 360, okay. This cancels, 3 12s are, I believe, and this is 12 pi, okay. So you can clearly see if you take 2 pi common, here you will have 60, right, omega t. So 2 pi 6t, right, 2 pi is taken common, and if you take 2 pi common from here, you will get 60, 1 by 60, right, 2 pi is taken common, you will get 1 by 60. So this is the correct equation, right. So a sine kx omega t minus kx was the form. Due to the direction, omega we found it out to be 12 pi. So if we take 2 pi common, it will be 60, and if you take 2 pi common from this, you will get 1 by 60, okay. So 60 and 1 by 60, okay. So that is x by 60, okay. So I hope this question is clear. Let's move to this one. Here we have been given a reaction. The binding energies of this, okay, 1, 2, 3 respectively are A, B, C. You are supposed to tell what is the energy released, okay, energy released in this process, okay. Of course, it will be in the form of difference in the binding energies, right? So this cannot be the option. It cannot be all plus, right? Unless this was any one of this was negative, okay. But yeah, this cannot be all positive, okay. Let's actually find it out. So what will happen? This is the binding energy of pair, right? This reaction is happening, it is favored, and Q is positive, right? We know that energy is released. There is that word, released. Okay, energy is released. So there is a stability increase. So here is the binding energy of daughter. Okay, we know that since this reaction is favored, energy is released, the binding energy of daughter will be greater than that of parent. Okay, and this difference will basically give you the energy that is released. So energy released is difference in the binding energy. So binding energy of the daughter, which is the higher binding energy, because stability is preferred, the reaction is occurring because it wants to go to a stable state, right? Stable product. Okay, stable product meaning a product that has higher binding energy as compared to parent. Okay, so binding energy of daughter minus that of parent. Okay, if this was given in terms of masses, the case would have been other way around. Okay, so anyways, here binding energy of the daughter is this one, helium is A, B, C, right? So helium is C minus binding energy of the parents is, this is A and this is B. Okay, so A and B, sum of that, so A plus B, or C minus A minus B. Okay, so the binding energy of the daughter minus that of the parents. Okay, so option B is correct over here. Okay, so I hope that is clear. Over to the next question. Question 9 and 10. In question 9, we have a charge capital Q, not small q, which is broken into two parts. Okay, Q1 and Q2. You are supposed to tell if they are placed at a distance r from each other, a fixed distance r, what is the maximum force of, when will be the maximum force of repulsion between them occur. Okay, when the charges are split in what ratio. Okay, half, half, 1/4, 1/4. What will be the correct choice over here? You can see that only one of the options actually add to q, right? This does not, this is half q, this is something else. Okay, okay, so this might be correct or this might be correct. Okay, let's see. So we have a charge q, it is broken into two parts. We can say q1, q2, or we can say this is broken into q. Okay, so this will be q minus q. So if you add them, the total will be q. Okay, so q and q minus q. Okay, so now the force between them is F k q1 q2 by r square, right? Or we can write k q small q into q minus q by r square. Okay, so basically my objective over here is to maximize the force. Okay, I'll just find the force and set its first derivative equal to 0. Okay, and check that the second derivative is negative, right? So here if I take force, we'll get k. I'll just open this up so that it is simple while derivating. Q minus q square by r square. Okay, now I'll take the derivative df by dq. You can see that the force depends on this q, right? Small q, how much of the charge you are breaking it into, q and q minus q. Okay, so it depends on this q explicitly. Okay, so we can take the derivative, that is force is a function of that small q. Okay, if we take the derivative and set it equal to 0, basically k and r square are a constant. You write them, you don't write them, no worries. Okay, basically you will equate it to 0, right? So if you take it on the other side, everything becomes 0. So k and r square, no need of writing them, and or I'll write them if you might get confused. And let's take the derivative now. Q derivative is q. Okay, because q is a constant, right? Total charge is constant. Small q is the one varying over here. So q derivative is capital Q, and q square derivative will be 2q. Okay, and now this, if you equate to 0, these two are constant, right? Not equal to 0. Take it to the other side, 0. So you get the relation q minus 2q is equal to 0, or q is equal to 2q, or q by 2 is equal to q. Okay, the small q should be equal to q by 2 so that the force is maximum. Or how maximum? Let's take the second derivative and prove that it is negative. Okay, second derivative, if you take k by r square, again constant, right? Positive constants, and if we take the second derivative, this is 0 and this is minus 2, right? So this is negative, meaning this is maximum. F is max, local maximum. Okay, so the maximum condition occurs when q is half. Okay, q is half of the total charge, so half and half of the total charge will give you a force when placed at a distance r, which will be the maximum at a constant distance r. If you have a total charge q, you can split it into q by 2 and q by 2 so that you have the maximum force. Okay, you can remember it directly. Okay, half at a constant distance will half the charge of the total at the constant distance will give you the maximum force. Okay, capacitor, coming to question 10, here we have a capacitor. With capacity, this electric potential is varying. Okay, so the voltage on the plate is varying as 10 to the power 12 volts per second. So this is the variation in the voltage. Okay, you are supposed to tell the displacement current. Now this current is simply given as C into dV by dt. Now you tell me you don't know this formula, and I'll tell you you know it. Okay, you know it very well, in fact. Okay, because you know that Q is equal to CV. Now just differentiate it on both sides. So dQ by dt is C, which is constant, dV by dt. Okay, don't you know it? Okay, so yeah, so this is the displacement current, or by magnitude displacement current, and your normal current is all the same, right? So I is equal to C dV by dt. So C is 12 picofarad, pico is 10 to the power minus 12, okay, and the rate of change of voltage is given as 10 to the power 12, okay. So is something wrong over here? Let me check the values. Okay, so the correction is here, it is 2 picofarad, not 12 picofarad. So 2 picofarad, and that will give us the answer 2 amperes. Okay, as simple as that. Option A is the correct choice over here. Okay, so that's about these two questions. Over to the next set of questions. Question 11 and 12. In question 11, we are supposed to find the effective resistance between A and B. Okay, this might seem complex. You might think of mirror symmetry and this and that, but no worries. You just have to focus over here. It's very simple actually. So if we take this point of connection as O, you can see that this 8 ohm is between A and O, right? So I can write this point as A. This point is also A because there is no resistor or something or any circuit element over here. So this point is B. This is also B. Okay. So this 8 ohm resistor is between A and O. This is also between A and O. This is between B and O. This is also between B and O, right? So we can redraw this. Okay, so we'll have A over here. Then we'll have this 6 ohm is between A and B, A and B. Okay, so 6 ohms, the case is simplified. Okay, so this is the 6 ohm. This is the 6 ohm between A and B. Okay, now we have a point O over here. So we have between A and O this 8 ohm and this 8 ohm. So basically they are in parallel, okay, between the same 2 points. So hence they are parallel. So this is 8 ohms, this is 8 ohms, and between B and O we also have 4 ohms in parallel, right? So 4 ohms, and this is also 4 ohms. Okay, now it's very simple to solve this. So let's first solve this. 8 and 8 in parallel, 8 by 2, right? So that will be 4 ohms, and plus this in series, this is 4 and 4 in parallel, which is 4 by 2, right? So R and R in parallel basically gives you R by 2, right? So 4 and 4 in parallel will give you 2. So in this branch we have 6 ohms, and in all the 3 branches we have 6, 6, 6, right? So this, if you simplify, is 6. So 6, 6, 6 in parallel, 6 by 3. Okay, so if you have R in parallel n times, it is R by n. Okay, so the equivalent resistance is 6, and the number of branches 3, 6, 6, 6, right? So 6 by 3, it's basically 2 ohms. Okay, you can solve it in your own ways. The circuit is simplified for you. I just did as a speed run it. Okay, or you can just try it yourself. Okay, you'll reach to the same answer. Okay, so let's come to this one. This is from SHM. We are given the amplitude of SHM as A, okay, and T is the time period. You are supposed to tell what is the maximum velocity. Maximum velocity is basically, you know it as A omega, right? The amplitude into omega. Basically the magnitude will be A omega, right? From where does this come from? So if you know the equation of SHM, it is A sine omega t, or A cos omega t, whatever you want to write. That won't change the magnitude of your answer. So if you differentiate this, you'll get velocity as A, and sine differentiation is cos omega t, and omega t, if you differentiate, it is A omega. What is the maximum value of this? This maximum is 1, right? Minimum is 0, or minimum is minus 1, maximum is 1. Okay, so the maximum velocity that you can obtain is when this vector is 1. These two are constant. When this vector is 1, you will get A omega, which will be the maximum velocity. Now omega, we are not given. We are given the time period. From time period we can obtain omega because t is 2 pi by omega, right? Or omega is 2 pi by t. Now you can see the answer, right? It will be 2 pi by t into A. So 2a pi by t. We just multiply this with a omega, right? So option C, that is correct. Okay, over to the next question. To question 13 and 14 over here. In question 13 we are given a ray diagram. Okay, the radius of curvature of the spherical surface is given as 15 centimeters. You are supposed to tell what is this distance x. Okay, mu1 and mu2 are also given, the refractive indices of this medium on this side and the refractive index of the spherical curvature. Okay, this spherical curvature. Okay, you can see that the ray is coming from a distance x. Okay, so we can say this is the object placed over here, so at a distance x, and the image will be formed at infinity, right, because this line is parallel. Okay, so the image will be formed at infinity. You can use the formula for spherical surfaces. Okay, refraction at spherical surfaces, it says mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Okay, mu2 being the second medium, the medium that ray goes into the second time. Okay, so mu2 is 1.5. we can see v is the image distance, where is the image formed at infinity, right, plus infinity in the mirror, okay, in the spherical surface. And then we have minus mu1 is 1, okay, and u object distance is minus x, right, minus x, because distances are measured from the pole of the surface. Okay, so minus x, and then we have mu2 minus mu1, so 1.5 minus 1, and that divided by r. Radius of curvature is 15, so we can see that this by infinity, basically a large number, so this will be 0, right. So this is 0 and this minus becomes plus, so 1 by x is 0.5 divided by 15, or x is 15 divided by 0.5, 1 by 0.5 is 2, right, because 2 half is 0.5, right, so 1 by 0.5 is 2, so 15 by 0.5 is 15 into 2. Okay, so that gives us 30 centimeters. As simple as that. It is straightforward application of the formula. Okay, and just simple logic over here. Okay, that the image will be formed at infinity and this distance will be x minus x. Okay, and yeah, just have to substitute. Okay, let's come to this one. Here we have an ideal gas which goes from point A to B. Okay, PV diagram is given by processes 1 and 2, different pathways. Okay, if the internal energy in the process changes as, so the internal energy changes in the first process as this, and in the second process as delta U2, you are supposed to tell the relation between delta U1 and delta U2. Okay, so it's pretty evident, you can see, because delta U is a state function, right, state function, and which means that it only depends on the initial and final point, initial and final point. Okay, so basically your delta U1, if you want to find, is final point minus internal energy at final point minus at initial point. Delta U2 is also internal energy at final point minus internal energy at initial point. Okay, so basically both of them are equal, right, because internal energy only depends on the initial and the final point. Okay, it does not depend on the path along which you take the process. Okay, so both of them are equal because internal energy is a state function. Okay, so that was the concept over here. Option C is correct. If this was work, then it would have been a different case, because work is not a state function. Work, heat are not state function, but your internal energy, which is the addition of the two, or by the third law of thermodynamics, first law of thermodynamics, is a state function. So internal energy is a state function, heat and work are not state functions. Okay, so basically the whole point is the internal energy will remain same irrespective of what process you take, provided initial and final point are the same. Okay. Question 15 and 16 over here. Question 15, we have a particle which is moving on a circular path. Radius is r. It moves from point A by an angle theta. You are supposed to tell the ratio of distance to that of magnitude of displacement. Okay, magnitude of displacement, because displacement is a vector, right? You cannot divide by a vector, so divide by its magnitude. Okay, so that is the thing. So distance basically will be the arc length, right? From A to B, what is the arc length? Okay, so arc length is given as r into theta, right? The radius times the angle. So r into theta will be the distance. So it's pretty simple for the distance. for displacement we have to work hard. Okay, so if you see, let's zoom in. So we have this triangle from A to B. I'll connect A and B. Okay, so if you see, the perpendicular will come somewhere over here, right? So perpendicular from A to B will not come on B. Okay, don't have that misconception. Okay, so here this is R from O to B, and O to A is also R, right? So you can see an isosceles triangle over here. Okay, isosceles triangle. I've just connected this point A and B. Okay, now what can we do? So this is isosceles triangle, so I can drop a perpendicular from this direction, okay, which will be also the angle bisector because it is a isosceles triangle, and also it will be an you can say the altitude or height. So this will happen. Okay, so basically we'll have two similar triangles, and this angle will get divided into half. Okay, so yeah, we have dropped a perpendicular bisector, which also becomes the angle bisector. Okay, so that we have two similar triangles. This is a property of isosceles triangle. Okay, so now we can see that what will be this distance. Now this is nothing but displacement, right? Displacement is the shortest distance between the final 2 points, initial and the final point. So between A and B. So this is the shortest distance because this is a straight line. We have connected A and B by a straight line. So we can say that this distance is x, or we'll say 2x. Okay, so that we'll find this x and x. Okay, so the total distance is 2x. Okay, just for simplicity. So we'll find this distance x and multiply it by 2 because the distance is 2 times of that, right? A to B is 2x. Okay, so we'll find this x. X is nothing but, you can see it is opposite, right? So opposite will be sine theta. So this distance is r, is the perpendicular. So this will be r sine theta by 2, right? Or let's forget. Okay, just write sine theta by 2 in this triangle. Okay, sine theta by 2 will be opposite upon hypotenuse. Opposite is x, hypotenuse is r. Okay, so basically the same thing. R sine theta by 2 is x. Okay, but the distance we know, the displacement is 2x, right, from A to B. So 2 times of this, 2r sine theta by 2. So this is the displacement, this is the distance. Take the ratio. So distance by displacement. Okay, so this is r theta, and this is 2r sine theta by 2. 2r sine theta by 2. R cancels. This is theta by 2 sine theta by 2. Okay, which is option B. Option B. Theta by 2 sine theta by 2. Okay, just a bit of geometry. This is a question from 2 dimension, since the motion is circular in a plane, motion in 2 dimension. Okay, so that is how you do it, some use of geometry. So let's see this one. We are supposed to find the magnetic moment. The magnetic moment is simply given as I into A, right? Mu is equal to I into A, or you can make it out from unit, ampere into meter square. So I into A, right? So I is, if you see the current, okay, the current was given. What is the current? I have to find it now. My bad. What chapter is that now? Okay, the current is given as 2 amperes. Okay, 2 amperes current. So let us find this now. So 2 amperes current, and the area is, this is a right angle triangle, or for triangle you can use half base into height, right? So I'll keep this as I. So I is 2 amperes. Now it is half base. What is the base? Base is 4 meters. Height is the altitude. This which is 3. Okay, so this cancels. 4 3s are 12 ampere meter square. Okay, which is option A. So option A is correct. Just mu A IA is the formula. So pretty straightforward. Let's move to the next one. Question 17 and 18. Question 17 is from electromagnetic induction, as you can see. So we have a current I which is flowing in this circular loop of radius r. You are supposed to tell what is the magnetic flux through a square loop such that its dimensions, the length is very less as compared to the radius. So basically this square loop is at the center of the loop. That is what it means. Okay. So the flux through the loop, through the square plane will be basically B into A, right? And if you see the magnetic field due to this current, it is clockwise, right? Clockwise, so magnetic field is inward. Okay, so at the center, or you can make it out from this rule also, you can place in the direction of the current, so magnetic field is inward. Okay, and the area vector is also inward, or you can say outward. So basically both are in the parallel or anti-parallel direction. Okay, so B dot A cos 0, or you can say B dot A cos 180, so basically a negative sign, but we are only concerned about the magnitude, as you can see from the options. So yeah, so we'll say cos 0, or basically the magnetic field and the area vector can be taken in the same direction. Okay, so basically we'll have B into A. Okay, cos theta, theta is 180 degrees, or you can treat it as 0. Okay, now B, what is the magnetic field? Now this square loop is very small, I told you, and can be taken at the center. So what is the magnetic field at the center of the loop? You know it, mu0I upon 2r, right? You find this formula using BITSAT law, and for a loop then we also find for a straight wire application of BITSAT law. Okay, so mu0I upon 2r, that is for a circular ring, right? So now what about the area? Now which area will you take? Will it be the area of the loop, or will it be the area of the square? Okay, pause the video over here and do write it down in the comment section. Okay, I'm going to reveal the answer in 1, 2, 3. Okay, the answer is the area of the square. Okay, because you are supposed to tell what is the flux through the square loop. Okay, flux through the square loop. So of course you will take the area of the square. So area of the square is L square. So the simple answer over here is this, mu0I. So I'll take it as capital, since that is the notation used in the question. mu0I L square by 2r, which is option B, right? Yes. So let's move to question 18. Question 18, we are given two sound waves, okay, which pass through a point simultaneously. You are supposed to tell what is the number of beats per second. Okay, what is the number of beats per second? Okay, so beats is basically number of beats is f2 minus f1, right? So the difference in the frequency give you the number of bits, right? So here from this you can find omega 1 and omega 2, right? Omega 1 is 122 pi, right? This is a sine omega t, and this is a sine omega t, right? Again, so 128 pi. Okay, so from here you can find f1 and f2, because omega 1 is nothing but 2 pi f1 means 122 pi, and here it means 2 pi f2 is 128 pi. Okay, so you can cancel pi, and so f1 will be half of 122, which is 61, and f2 will be hertz, and f2 will be half of 128, which is 64. Okay, so f2 minus f1, which is the number of beats, will be 64 minus 61, which is 3. Okay, or if you had taken this as omega 2, that as omega 1, no worries. Okay, you just have to take bigger frequency minus smaller frequency, that will give you the number of bits. The number of bits is 3 over here, option D. Okay, so that's about these two questions. Over to the next question. Let's discuss these two now. We have 3 blocks being given. Okay, the figure was also given. This is the 4 kg block, this is the 2 kg block, this is block B, and then we have a 1 kg block. Okay, so they are kept on a frictionless surface. A force of 40 Newton is applied on the block A, so that will distribute among this system. Okay, you are supposed to tell what is the force between A and B. Okay, so our approach is going to be simple. You can see it is a constant motion, right? When you apply a force on this block A, all of them will move together with the same acceleration, right? A will apply on B, B will apply on C, and as a result all of them will move with the same acceleration. It's a constrained motion. Okay, so we'll treat it as a system, okay, and we'll find the acceleration. Force is equal to mass into acceleration, implies the acceleration on this entire system. I'm treating them as one block, okay, of 4 plus 2 plus 1, 7 kg. Okay, so that will give us force by mass. Acceleration will be given as force by mass. Force is 14 newtons and total mass is 4 plus 2, 6, 6 plus 1, 7. Okay, so the acceleration is 2 meters per second square. Okay, Now we know that the total force that is being applied on the system is 14 newtons, and some of it is used to move A, right? So we'll subtract that force, okay, 14 newtons. From 14 newtons we'll subtract the force that is needed to move A, okay. So we'll be left with the contact force between A and B, okay, because if you remove the force that is required to move A, the rest of the force remaining will be the force required to move B and C, okay. So that is the logic. So if you want to find the contact force between A and B, you just take the entire force minus the force required to move A, okay. That's simple now. So total force is 14 newtons. We have to subtract the force needed to move A, okay. Force needed to move A will be mass into acceleration. We know that the acceleration whole system is 2 meters per second square. The entire system is moving with the same acceleration. 4 kg is also moving with the same acceleration, okay. So mass is 4 kg, acceleration is 2, so that gives us 8 newton. So 8 newton is needed to move the block A, okay. So total force is 14 newtons minus 8 newtons, 6 newtons. That is the force between A and B, or the rest of the force that is required to move B and C, okay. So this is the contact force between A and B, okay. So total force minus force required to move A, which is 6 newtons, option B. Let's come to this one. This is very simple. You're supposed to tell the relation between the fringe width for red light and yellow light, okay. So we know that fringe width is given as lambda capital D by small d for a given apparatus of your double slit experiment. You know that D and D will be constant, right? They will be some constant. The spring will be placed at the screen will be placed at certain distance, and the D, the fringe width will be, the slit width will be also a constant, okay. So you can see that beta explicitly depends on lambda, okay? It only depends on lambda. So higher lambda means higher fringe width, okay. So if you see who has the highest wavelength among this, yellow, then red, right? Red has the higher wavelength, okay. So lambda for red is higher, okay. Lambda increases along this direction. So lambda for red is higher, so beta for red is higher than beta for yellow, okay. As simple as that. So beta for red is greater than beta for yellow. You can see this is saying the opposite thing. They can't be equal, okay. There is a difference in the wavelength, and here also it is saying that red should be half of yellow. Red cannot be less than yellow, right? So this is also wrong, okay. Only correct option is red should be higher than that of yellow, okay. The fringe width of red is higher than yellow. So that is question 20. Over to the next one. Question 21, 22, okay. Just a few questions left after this and we'll be done with the mock test. So yeah, stick around and let's get this done. Okay, so here in question 21 we have a solid sphere as shown. It is rotating with an angular speed omega on the horizontal plane, radius r. You are supposed to tell the magnitude of the angular momentum, okay. Now angular momentum will be due to two reasons. One is the translational angular momentum, which is one is due to the translational your momentum, which is linear momentum, which is simply r cross p, okay. And you are supposed to find about the origin, right, about this point. And one will be due to the rotation, which is I omega, okay. So r cross p is this r over here, okay. You can see that. Let's find r cross p over here, okay. R cross p is basically r p sine theta, right. And if you see r and v is in this direction, right, velocity of the center of mass will be along that direction, okay, translational. So momentum is along that direction and r is along this. So r cross v, okay, r cross v will be inside, right, and omega is also inside. So both of them are going to add at the end of the day. So omega is like this, so that is also inward, and this r cross p, okay, from r to p, r to v, you can see that it is also inward, I believe. Yeah. So now if you see, this is nothing but, I'll take r sine theta, okay. So if we take this angle, this is nothing but theta. You can see that, right, between r and v is theta. This is theta, then this is also theta, okay. So that is your theta, and r and v, the angle between r and v, or r and p we can say, because velocity is the one that gives angular moment, linear momentum the direction, right. So if you see the same angle is over here, theta theta, corresponding angle, right? So r sin theta, I can write it as r perpendicular. So basically, if you want to write the, you can remember this, if you want to write the magnitude of angular momentum r across p, then you just can use this formula. Okay, so I can write this somewhere. Okay, please remember it. The magnitude of angular momentum is r perpendicular and p. R perpendicular is the perpendicular distance. As you can see, this is the distance r sin theta, right? The perpendicular distance between your linear momentum and your point, right? Point is O. Okay, you can see the perpendicular distance is r sin theta. This is r, so this is r sin theta, right? Opposite to theta is r sin theta. So yeah, we have r sin theta, or r perpendicular, you can call it. So that is nothing but the radius, right? It is always equal to the radius. You can see that. Okay, so r perpendicular is nothing but r into p, or p is mv. Shall we write that? Okay, we'll write that mv. Okay, so here we will have mv and r being the radius. Okay, you know why? Because r perpendicular, so r sin theta is nothing but equal to the radius. Okay, I is the moment of inertia of a solid sphere. It is 2 by 5 mr square, right? I hope you remember this, and this will be omega. Okay, we'll keep omega as it is. What can we do more? Okay, I'll convert this v as r into omega. Use the pure rolling condition. Let's not mention. Okay, so v is r omega. So this will become m r omega square, right? If you substitute v as r omega, this is r square and omega, and plus 2 by 5 m r square omega. Okay, so 2 by 5 plus 1 will be 7 by 5 m r square omega. Alright, 5 plus 2, 7 by 5. Okay, so which is option A? Okay, I hope you were able to get this idea. Okay, so angular momentum will be r cross p due to translational momentum, which is your linear momentum, plus the angular component, which is I omega, right? Let's come to this one. We are supposed to guess the correct graph between kinetic energy of a photoelectron, basically in a photoelectric effect, and the inverse of a wavelength. Okay, so if you see, inverse of wavelength will be proportional to basically your frequency, right? Because hc by lambda, you can say, is also h nu. Okay, these are all constants, so 1 by lambda is proportional to frequency. Okay, so basically we are searching for a graph of kinetic energy, maximum kinetic energy with frequency. Okay, something of that sort, just moved by a factor. Okay, because of the constants. Okay, so Ke, we know that from the photoelectric equation, kinetic energy maximum will be the energy supplied minus the work function, right? So energy supplied you can write as h nu, and this as h nu naught. Okay, some threshold frequency. This is maximum kinetic energy. So this is h can be taken common, and you can write it like this. So you can see that kinetic energy is in a way directly proportional to your frequency, okay, or directly proportional to inverse of wavelength, because that is the relation, right? Inverse of wavelength is nothing but frequency in a way. Okay, so it is directly proportional to frequency, or directly proportional to the inverse of wavelength. Okay, or inversely proportional to wavelength. So yeah. So that is the relation we obtained. So it will be a straight line, right? The logic says it will be a straight line, and you can also see why it won't begin at here at the origin, because it has some factor nu naught in it. Okay, when your nu is equal to nu naught, kinetic energy will become 0. So at this point, kinetic energy is 0, because nu is equal to nu naught, kinetic energy is 0. Okay, so after points greater than nu naught, so greater than nu naught, okay, or 1 by lambda naught I shall say, because this is in terms of lambda. So after points those nu greater than nu naught, will have a straight line. Okay, so that is the factor nu minus nu naught. Okay, so you can directly see from here also it will be a straight line. None of the others are a straight line, only A represents a straight line, and you can see the logic why it does not begin at the origin. Or you might directly know the graph of kinetic energy versus frequency. In whatever way the correct choice over here is option A. Okay, so that's with this question. Over to the next one. Come to question 23 and 24. In question 23, we have an hydrogen atom which is excited to a principal quantum number n state. It emits a wavelength lambda for a photon. When it is coming to the ground state, you are supposed to tell what is the value of n. Okay, so basically use the redox formula and find n from there. Okay, so 1 by lambda will be r into 1 minus n. This will be initial and this is final, right? So 1 by lambda, sorry, this is final, this is initial. Okay, okay, finally, final minus initial, right? So r here, finally it comes to the ground state, right? Initially it is at some excited state n, finally it comes to ground state, so n final is 1. So basically square is also 1, so we need not write that. Then we have n initial is some n quantum state, okay, excited state, sorry. So we are supposed to find this n. Let us try and find it out. Yes. So lambda is 1, this 1 by n square. You can take this to the other side. 1 by n square is 1 minus 1 by lambda r. So 1 by n square is lambda r minus 1 upon lambda r. So n will be, so from here n will be square root of, so just take the reciprocal and square root, right? So this will be lambda r upon lambda r minus 1, okay, which is option A, right? So option A is the correct choice over here, lambda r upon lambda r minus 1. Okay, let's come to this one. Here we have been given a PV graph for a diatomic gas. Okay, you are supposed to tell the change in the internal energy. Now change in the internal energy will be basically Fr by 2, so Cv dt, right? Or n also is there, number of moles. How did this come from? This came from basically your U is equal to NCV dt, right? Change in internal energy is NCV dt, and Cv is nothing but Fr by 2, the degrees of freedom into R by 2. Okay, so from there we reach over here. Okay, yes. So F for your diatomic is 5, right? 5 degrees of freedom for a diatomic molecule, 3 translational and 2 rotational. So delta U is F R, so 5 by 2 into N R delta T. Now we can use the ideal gas equation because everything is in the form of PV, right? Not nRT. So we can use PV is equal to nRT. Okay, the pressure is constant over here, so if we use difference, P delta V is nR delta T, okay, which we are supposed to find, right? So nR delta T will be P into delta V. So 5 by 2 into P into delta V. P into delta V is nothing but change in volume is final volume minus initial volume. So V2 minus V1. So 5 by 2 V2 minus V1. Okay, 5 by 2 V2 minus V1. P V2 minus V1. Okay, so that is option B. So that will be our correct choice. So let's move to the next set of questions. Now discuss question 25 and 26. In 25 we have a candle which is burning inside a cylindrical container. This capital D is the diameter, is very big than the diameter of your cylindrical candle. Okay, so if it burns at the rate of 2 centimeters per hour, the top of the candle will remain at the same height, fall or go up, fall with this rate, fall with this rate, fall or go up with this rate. Okay, now you can do this with common sense. Okay, the options I would say are loose, okay, very loose. You can break it up, okay, because if you see what is happening, the candle is burning, the top part will be removed, right? 2 centimeters. After 1 hour, 2 centimeters from the top will be removed. Okay, so the mass on the top will decrease. Essentially, the mass of the entire candle will decrease after 2 hours, right? So because 2 centimeters are being burned out. Okay, so the mass will decrease. So the force in the downward direction will decrease because mg is in the downward direction, right? Mass decreases, so force in the downward direction is decreasing. In order to keep it in equilibrium, the upthrust will also increase. Okay, upthrust will increase. Upthrust will be the same, so mg is decreasing, upthrust is the same, so it will be pushed up. Okay, initially U and mg are balanced. Okay, but when a part of the candle is burned out, okay, the upthrust is the same, but mg has decreased. Okay, so the upward force is more. Okay, so the candle will go up. Candle will go up. Only one option says that the candle goes up, and one has to be correct. So option D is correct. Okay, but that is not the way I'm going to do this. We'll use the concept. Okay, so initially we know that U is equal to mg. Okay, so initially how is U given? U is upthrust is given as volume immersed, volume that is inside the liquid, density of the liquid into G, right? This is mg. G can cancel, so we obtain the mass as volume immersed. Volume we can write as the area of the candle. Now this area is area of the candle, not the container, right? The thing that is immersed. So area of the candle. Now volume immersed, right? This volume is immersed, only L height. So area into length. L is immersed, not 2L. Okay, L is immersed. So AL is the volume immersed and the density of the liquid. We'll simply write it as rho. Now after 2 hours, what will happen? 2 hours, after 1 hour, 2 centimeters is burned out. Okay, 2 centimeters is burned out. Now what will happen is, I told you there will be a force in the upward direction, right? You can also consider the candle going down. You can take my, I'm going to consider that after 2 hours, the candle goes up. Okay, you can also consider it going down. You'll just get a negative answer, which means the opposite, right? I'll assume that it goes up by L by some distance x. So the length inside the container becomes L minus x, and above the container becomes L plus x, right? Now we also have to consider, now again I can balance the forces. I can say that mg is equal to upthrust, right? When it is after 1 hour, 2 centimeters are burned out, and it has risen by x centimeters. Okay, and then again it is in equilibrium. Okay, for the R to come. Okay, but here the mass has changed, right? Because some part of the candle is burnt out, right? So mass has changed. So m prime I'll use. Upthrust is the same, I told you. So let us consider this case now. So this is finally, right, after 2 hours, after 1 hour, after 1 hour. Okay, so what will be m prime? First of all, m corresponds to 2L. 2L of the candle gives us mass m. Okay, m prime will be 2L minus 2, right? 2 centimeters are burnt out. Okay, so 2L minus 2, total length minus 2. So m prime will be basically, you just crisscross. Okay, m prime will be m into 2L minus 2 upon 2L. Okay, so basically m into 2 can cancel throughout, L minus 1 upon L. So this is your m prime. Okay, so I can use it. M is L minus 1 upon L. Okay, and this is G. Now upthrust will be volume immersed. I told you this is volume immersed, density of the liquid into G. So volume immersed is again, area is the same. Okay, candle does not burn by side but by the layer, right? So area is the same of the cross section of the candle. Length has become L minus x inside the container, inside the liquid, and G is same. Okay, of course G gets cancelled. Also M, we know it from the initial condition. The actual mass is AL rho, right? So we'll have L minus 1 on L. So this is a slightly tricky question, but that's why I did it. I'll also tell you a short trick. A cancels, LL cancels, and something is missing. Okay, rho is missing over here. So rho also gets cancelled. So if you compare this, you'll get L minus 1 is equal to L minus x, right? So x is nothing but 1 centimeter. So it rises by 1 centimeter per hour, right? This is just a case for 1 hour. Okay, we can see it again and again, and it will be every time it will be rising by 1 centimeter per hour. Okay, now that was the long way of doing it, but the shorthand way, you can see that initially the candle equal length is outside and inside, right? Equal length is outside and inside. Now when the candle burns for 1 hour, 2 centimeters are gone, right? 2 centimeters are gone. So what will happen? This 2 centimeters have to again divide in such a way that there is equal length outside and inside your liquid. Okay, so it has to rise by 1 centimeter. Okay, so 1 centimeter it has to rise, so that the length inside the conductor inside the liquid and outside the liquid remains the same. Okay, 2 centimeter 1 1. Okay, that's how it adjusts, and you obtain the same length after 1 hour. So basically it has to rise by 1 centimeter so as to maintain the same length inside and outside the liquid. Okay, let's come to this question. This might seem tricky. Okay, we have an arc which is divided into 120, 120, 120. Resistances are shown. This length has R, this length has R, this has 2R. Okay, now what is the magnetic field at the center O? Okay, this is the center O. Okay, now it's very simple. Okay, and the most important statement is given in the bracket over here. Okay, so this says that current enters through A and leaves through B and C. So essentially current is going like this, okay, no current is entering here. Okay, there is no current over here. Okay, so that part is useless, right? There is no contribution, no current in that part, so no magnetic field due to that part, right? So if you see I is coming and it encounters two resistances which are in parallel now. Okay, if you see here it is R and here also it is R, so what will happen to this I? This will become I by 2 and this will become I by 2. Okay, this is useless, I told you. Okay, so I splits into I by 2 and I by 2 because the resistances are equal, otherwise you had to take the ratio. Okay, now you can see that it is symmetrical, right? You can see that current will be in this direction and in that direction. Okay, so due to the arc which is on top, the current is, the magnetic field due to the current at point O is inward, and due to the point which is down, the current is outward, right? You can place the thumb in the direction of the current and see that for the top one it is inward, for the down one, okay, it is outward. Okay, so both of these will cancel out each other, right? Because B at the center is mu 0 I upon 2R. Okay, here basically each value of I is I by 2, so this will give us mu 0. I'll substitute I is I by 2. Okay, so this is B1 due to the top part, mu 0 on 2R, and this will have due to the top part. Okay, this will be in the inward direction. Okay, and B2 is again mu 0 I upon 2R, and this R, mind you, is the radius, not the resistance. Okay, mu 0, the resistance was given so that you can divide the current. Okay, and this is again I by 2, right? And this is in the outward direction, so they will cancel out each other, and effectively the answer is 0. Okay, so that was the logic behind this question. Over to the next one. So question 28 and 29. In question 28 we have a charge in an electric field, okay, which is released, and you are supposed to tell the kinetic energy after traveling a distance y. Okay, so it's very simple. We can use we can directly use the kinetic energy, work energy theorem will be change in the work, basically the work done. So what is the work done over here? Force into displacement, the distance is y, force is QE, so answer is QEY. Okay, as simple as that. Okay, or you could have used you could have found the acceleration and then use s is equal to ut plus half at square. No, v square is equal to u square plus 2as, find v square from there, and then you can find half mv square. That's a long procedure. Or you can use work energy theorem. Okay, you are supposed to find the maximum output voltage in this circuit now. Now you can consider any cycle, the positive cycle or the negative cycle, it will be identical. So if we consider the positive cycle, this diode we can short, right? This will open up because this diode will be forward bias. This is positive to positive, so forward bias, this is reverse bias, open it up, no use. Okay, then we have 2k over here, then we have also 2k over here, finally we have also have 2k in this right branch, so 2k. Okay, so this is how the circuit looks. Now we can find equivalent resistance that will help us find this current that is arriving at this junction I. Okay, then it splits, right? So there is twice the resistance over here and 1 times. Okay, so let us find the equivalent resistance first. I can see this is 4 and 2 in parallel, right? These two are in series and this is parallel with this. 4 and 2 in parallel gives 4 by 3, right? R big by 3. So basically you have R and 2R in parallel, you get the bigger value by 3. Okay, So that is a short trick I remember. You can calculate it. Okay, 4 and 2 in parallel, product upon sum, right? So so that is the equivalent resistance that we get. Okay, now what can we do? Okay, so what is the current through the circuit? Current at 10 volts. Okay, since we want the maximum output, we'll consider the maximum input. So I is V by R, so 10 by 4 into 3, okay, 4 by 3, so 3 goes on top. So this will give us 2 5s are and 2 2s are. So this is 15 by 2. That is the current that is leaving the circuit. Okay, and in milliamps, because this is in kilo ohms. Okay, everything is in kilo ohms. So the current is in milliamps. Okay, anyways, those factors will multiply to give us the voltage. So voltage will be in volts only. Okay, so now we have to find the current. We have to find this output voltage VO across this resistor, right? So what is the current in this branch? Okay, in this branch. So 2K and 2K, we have this, and one more 2K. So this is the simplified version. So current I, which is 15 by 2, is coming over here. It will split into I1 and I2. Okay, so what is the value of I1? Okay, because I1 into 2 will give us the VO, right? I1 into 2 will give us the output voltage. Okay, so how do we find I1? We can use the current divider rule or whatever, or you can use simple logic that it is 2 2 4 in the top branch, okay, and 2 in the down branch, right? So 2 times the resistance. So total, if we can split the current in 3 units. Okay, I'll divide it into 3 units. So I is there, so I'll break it into I by 3 and 2I by 3. Okay, okay, so if you add them, you get I, right? So 2/3 of the current will go in this branch, and 1/3 will go over here, because higher resistance, lesser current. Because, and you can multiply and see, 2 2s are 4, 4I by 3, 4 into I by 3 is 4I by 3. Okay, so the voltage drop across the parallel branches is the same. That is the logic I am using. Okay, or you can use the current divider rule. Okay, so now, so I by 3 is the current which is going through this branch. Okay, so I by 3 into 2 will give us the output voltage. So I by 3 is 15 by 2 and that by 3. So this is 15 by 2 is I by 3 into 2, 2 cancels, and 3 5s are. Okay, VO is 5 volts. Okay, now I1, so our correct answer is 5 volts. I1, I can also, if you want to know the current divider rule, how do we write it? I also forgot about it. So here, into the other resistor upon the sum of the resistor. I think this is correct. So we get, what do we get from here? 5, so we get 15 by 6, right? Or 5 by 2. Okay, 5 by 2. Is that the current in the branch 1? So yeah, right? So I1, you can, so basically I was calculating how to find I1. If you didn't understand this logic, this is how I balance the voltage in the two branches. So if you want to find I1, you can also try this. So the total current is 15 by 2, right? You can use this formula, total current, net current, divide into the other resistance upon R sum. Okay, so I net is 15 by 2, that is the current that is appearing at the branch. What is the other resistance? You want to find the current in this branch, right? What is the other resistance? 2. Okay, and sum is sum of all the 3 resistors, okay, all the branches. So 2 plus 2 is 2 plus 2 plus 2, 6. Okay, so this will give you 5 by 2, which is also I by 3, right? I by 3, if you do, it's 5 by 2, right? So you can use this logic or this logic. So that gives you I1 into 2, basically, because this is the value of R. I1 into 2 will give you the voltage. Okay, I hope that is clear. Over to the last question for the day, and question 30 will be your homework question. Come to question 29, the last question for the day. The question 30 will be your homework question. Okay, so let's see what this question is saying. So we have a particle which is released from a height s, okay, from the surface of the earth. Okay, at a certain height, its kinetic energy, so let's suppose at this height h, its kinetic energy is 3 times its potential energy. So you are supposed to find the distance from the earth and the speed of the particle at that instant. So you are supposed to find this h, and what is the velocity? Let us call it v1 at that point. Okay. So now v1 will be easily given as under root 2g, the height that it has fallen, h prime we can call it, right? So this is h prime, this height, okay, s, okay, I will take s a little bit above. Okay, so this height that it has fallen is s minus h, right? So s minus h is the height it has fallen. Okay, so basically this h prime is nothing but s minus h. This comes from conservation of your energy. Basically the velocity gained by an object which is released from a certain height, which falls a certain height h, is given as under root 2gh. So this object has fallen a height s minus h, right? S minus this h. Okay, so that is the velocity gained by the particle. Okay, so this is the velocity at that instant at which kinetic energy is 3 times its potential energy. Okay, so let's use that condition now. So what is the kinetic energy at this point? Half m v1 square, right? Velocity is v1, so half m v1 square is the kinetic energy. It's 3 times the potential energy at that point. So 3 times the potential energy, which is mgh. Okay, now we can cancel this m and m. Okay, half v1 square will be 2g, so square root will get cancelled, s minus h, and we'll have 3gh, so g gets cancelled, 2 gets cancelled, and we have s minus h is equal to 3h, right? So s is equal to 4h, or h is equal to s by 4. Okay, so 3 s is equal to h is equal to s by 4. Let me check that. Yeah, that is correct. Okay, let's solve it further, and we are also supposed to tell the velocity at that point, right, which we assumed as v1. v1 will be under root 2g this s minus h. S minus h, you can do it. So s minus h, from here directly you can substitute, or you can use s h as s by 4, or you can use actually we'll use that because we want the answer in terms of s, right? So s minus h, so s minus h is s by 4. Okay, so 2g, this will be 3/4, right? 1 minus 1/4 is 3/4. So we get what is this? 2 can cancel this, so we have 3gs by 2. Okay, is that answer? Yes. Okay, option B is the correct choice over here. Okay, because you get the height as s by 4 and the velocity as 3g under root 3gs by 2. Okay, so that is our correct choice. Over to the final question, which will be your homework question. Pretty much it for today's video. This is question 30. This is your homework question. You can pause the video over here, take a screenshot and try it. Okay, and do let me know the answers in the comment section. The correct answer receives a heart from me. So that's pretty much it for today's video. I hope you really enjoyed it, and this will help you in your goal towards your securing your goal towards BITS, okay, in the branch of your choice. And if you found it good, do consider liking this video and subscribing. There are more mock tests that we did in 2022. I'll put the playlist link in the description. So if you want to check out the previous mock test 1, 2, 3, 4, 5, 6, you can check it out over there. The links will be available in the description. Again, thank you Photo Club for allowing me make this video, and the links to their website are available in the pinned comment. You can check it out, pinned comment, and also in the description. So you can check it out if you want to see their mock test or their book. Okay, so that's pretty much it from me today. This is me signing off. Keep enjoying physics.